Hello students, this is Mrs. Jennifer De Cruz from Lilavati Lalji Dayal High School and College of Commerce. And in today's Science 1 class students, we are going to study chapter number 3, Chemical Reaction and Equations. So before starting with this interesting chapter students, let me tell you all that the total weightage of this chapter is 6 marks with option and 4 marks without option. So let's begin with this interesting chapter. So students, in this chapter, we shall study the following terms. We will study about chemical reactions, rules for writing chemical reaction, balancing a chemical equation, and types of chemical reaction. So let's begin with the first topic, that is chemical reaction. So students, in the earlier class, we've already seen how compounds are formed by chemical combination of elements, okay? We have also learned that the formation of a chemical bond is to attain an electronic configuration with a complete octet. Okay, the atoms, they attain a complete octet by giving, taking, or sharing of electrons with each other. So what is chemical reaction, students? It is basically a process in which some substance undergo bond breaking, okay, and are transformed into a new substance by formation of new bonds. Okay, so basically there are equations that makes use of chemical formulae and symbols to represent a chemical reaction. The left hand side of a chemical equation represents the reactant and the right hand side represents the product. These entities, students, they are separated by a symbol that describes the direction of the reaction. And each reacting entity is also assigned its corresponding coefficient. Let's understand the rules for writing chemical reaction. So students, we have to consider certain rules when we are writing chemical reaction. So what are they? Let's see. First rule is the reactants are written on the left-hand side, while the product on the right-hand side. An arrow is placed in between them. Next one, if the reactants and product are 2 or more, they are linked by a plus sign. To make the chemical reaction more informative, the physical states are indicated in the equation. Fourth, when heat is to be given from outside to bring about a reaction, it is indicated by the triangle diagram that is being shown. Fifth rule, it is necessary to fulfill certain conditions like specific temperature, pressure, catalyst, etc. to bring about some reaction. These conditions are indicated below or above the arrow. Last rule, special information or names of reactants and products are written below the formulae, example, concentrated or dilute. Let's see what the next slide is trying to tell us. Here now we are going to learn about balancing a chemical equation. Okay, so students, urine, okay, there are certain steps which we need to follow how to balance the chemical reaction. So first one is write the chemical equation from the given word equation. Okay. Second step, check whether the equation is balanced or not by comparing the number of atoms of the various elements present on the two sides of the equation. Step number 3, it is convenient to start balancing an equation from the compound which contains the maximum number of atoms. Moreover, it is convenient to first consider that element in this compound which has unequal number of atoms on the two sides. The last step is write down the final balanced equation again. Okay. Let's move on to the next topic, and that talks about types of chemical reaction. So as you can see, students, there are 5 types of chemical reaction that is there. First one is the combination reaction, wherein the equation will be A plus B giving you AB. Second reaction is the decomposition reaction, wherein AB will give you A plus B. Single displacement reaction, students, the third one, it tells that A plus BC gives you AC plus B. Then we come to double displacement, that tells us AB plus CD gives you AD plus BC. And the last one, combustion, that is CXHY plus O2 gives you CO2 plus H2O. Now, students, we will study each reaction in detail. So, first reaction, students, is the combination reaction. Okay. So, what is a combination reaction? So, reactions in which two or more reactant combines to form one product. Okay. This is termed as the combination reaction. Okay. So, here in students, you can see the example that is there. So, when magnesium is burnt in air, okay, magnesium oxide is formed. And in this reaction, magnesium is combined with oxygen. So you can see the equation out here. Mg plus O2 gives you 2MgO. Okay. Moving towards the next reaction, that is decomposition reaction. So here in students, okay, in this reaction, there is only one reactant in the chemical reaction. So let's see what decomposition reaction is all about. So reactions in which one compound decomposes in two or more compounds or element are known as decomposition reaction. So decomposition reaction, students, is just the opposite of combination reaction. For example, here when calcium carbonate is heated, it decomposes into calcium oxide and carbon dioxide. So if you can see the chemical formula here, CaCO3, calcium carbonate, when burned, when heated, it gives you CaO, that is calcium oxide, plus CO2, that is carbon dioxide. Let's move on to the other reaction, that is displacement reaction. So students, what is displacement reaction? Okay, when reactions in which, okay, the place of the ion of a less reactive element in a compound is taken by another more reactive elements by formation of its own ions, it is called as displacement reaction. We can understand this better by looking at the example that is there. When zinc reacts with copper sulfate, it forms zinc sulfate and copper metal. That is Zn, zinc plus CuSO4 gives you ZnSO4 plus Cu. Okay. So here in students, when zinc granules are added to the blue colored copper sulfate, that is CuSO4, then zinc ions form. Okay, they form zinc atom. It takes place in Cu2 plus ions in CuSO4, and copper atoms are formed from C4 2 plus ions, and then we get a more reactive, okay, then the more reactive zinc displaces the less reactive copper from the copper sulfate. That is zinc, okay, when it reacts with copper sulfate, it will give you zinc sulfate plus copper metal. Okay, let's move on to the next reaction, that is double displacement reaction. So what is double displacement reaction, students? Urine, the reaction in which the ions in the reactants are exchanged to form a precipitate are called as double displacement reaction. So there are two types of double displacement reaction. One is endothermic and the second one is exothermic. So students, for understanding double displacement better, I can give you examples, that is solutions of sodium chloride and silver nitrate. Okay, they react with each other, forming a precipitate of silver chloride and a solution of sodium nitrate that is there. So students, what is endothermic reaction? So your students, heat from outside is absorbed during some physical changes. For example, the melting of the ice. Okay. So during this process of melting of the ice, heat is absorbed by the ice. Second one is exothermic reaction. That is, heat is given away during some physical changes. For example, formation of ice from water vapor. So in this process, students, there is an evolution of heat leading to a rise in temperature. Okay. Otherwise, the formation of ice from the water vapor won't take place. Okay. So this is what exothermic reaction is all about. Let us move on to the next topic, students. That is factors affecting chemical reaction. So there are 5 factors that affect chemical reaction. Let's study them in detail. So first factor is the nature of reactant. Okay. For example, if both aluminium and zinc react with dilute HCl, H2 gas is liberated and water-soluble salts of these metals are formed. So aluminium metal reacts faster with dilute HCl than with the zinc metal. So aluminium is more reactive than zinc. Therefore, the rate of reaction of aluminium with HCl is higher than of zinc. Therefore, students, the nature of reactivity of reactants influences the rate of chemical reaction. Second factor is size of the particles of reactants. So students, urine, I'll give you an example again. In the reaction of dilute HCl, okay, and the Shabat tiles, CO2 effervescence is formed slowly. It means the rate of reaction depends upon the size of the particles of the reactants taking part in the reaction. That is, smaller the size of the reactant particle, faster is the rate of reaction. Third factor, students, is concentration of the reactant. So in the reaction of dilute HCl, students, CaCO3 disappears slowly and CO2 also liberates slowly. So on the other hand, the reaction with concentrated HCl takes place rapidly and CaCO3 disappears fast. So concentrated acid reacts faster than the dilute acid. That means the rate of reaction is proportional to the concentration of reaction. Fourth factor, students, is temperature of reaction. So limestone, student, on heating, it decomposes to give CO2, which in turn turns the lime water milky. On the other hand, the lime water does not turn milky before heating the limestone because of zero rate of reaction. So from the above example, we can understand that the rate of reaction increases on increasing the temperature. The last factor student talks about the catalyst. Okay. So the substance in whose presence the rate of a chemical reaction changes without causing any chemical change into it can be termed as a catalyst. Okay. So these are the 5 factors that are affecting chemical reaction. First, nature of reactant. Second, size of the particle of reactant. Third, concentration of the reactant. Fourth, temperature of the reaction. And last one is catalyst. Let's move on to the next topic, students, and that talks about oxidation and reduction. Okay. So what is oxidation, students? Oxidation is nothing but the chemical reaction in which a reactant combines, okay, with oxygen and loses hydrogen to form the byproduct. Okay. This is termed as the oxidation reaction. Okay. Now, in simple terms, the chemical substances which bring about an oxidation reaction by making oxygen available, okay, can be termed as oxidizing agent. The next one is, students, the next slide is the chemical reaction in which reactants gain hydrogen and loses oxygen to form the byproduct are called as reduction. Okay. So in reduction, students, what happens? The chemical substance that brings about reduction is called as a reducing agent. Okay. Let's move on to the next topic. That is corrosion. Now, what is corrosion, students? It is the wearing away of metals due to chemical reactions, mainly oxidation. In this process, metals lose their metallic properties. This causes a lot of damage to the car bodies, ships, bridges, iron railings, and to all the objects made of iron. Iron is used in a lot of places like the construction of bridges, tools, pipes, heavy machinery, etc. Let's move on to the next topic, students, and that is rancidity. Okay. So what is rancidity, students? Food, it turns rancid, okay, when the fats and the oils within them get oxidized and the taste and smell of the food changes. Okay. So oxidation of fats, it generates highly reactive molecules in the rancid food, which is responsible for the unpleasant odor and flavor. These chemical reactions also reduce the nutrition of the food. Okay. So food turning rancid when fats and oil gets oxidized is termed as rancidity. So with this, students, we've completed this chapter. Thank you.